thing I'm going to have up here first is the steps that you go about solving the exponential equation. The log ones you worked with in the last homework. Okay, ones you might encounter today are just going to be a little bit more involved, like expanding and knowing what the set equals each other and so on. The exponentials, though, you wouldn't have done last time. So the steps, there's 3 steps that I kind of say that you need to go through solving these exponentials out. And the first one, when I say isolate the exponential expression, that means if you've got like 3 to the x plus 1, that would be your exponential expression. That needs to be by itself on the one side. If you've got something multiplied by it, like a constant, it needs to be divided to the other side. If you've got something that is subtracted to it, you move to the other side of the equation. Just simply on one side, you need simply the exponential part of it. Okay? Next thing would be you take the log of both sides. In this case, it doesn't matter if you do log or natural log, it doesn't matter. Whatever you feel more comfortable with, you're going to get the same answer either way. Okay? Because you're going to start, because to get your final answer, you're going to be dividing by like log of 5 over log of 4. So whether you use log or natural log, it's going to come out to be the same exact answer. So at that point there, it's up to you whether you want to do log base 10 or natural log. Okay? And of course, if I've got like e in the equation, I have to stick with natural log because that'll cancel the e's out. Yeah?
When you say to bring down the exponent thing,
Yeah.
is that, wait, what is that?
Well, that's like if I had like, what did I say, like 3 to the
X
x
plus
plus
1.
whatever.
1.
When I take the log of that, right, it's going to become technically log. What happens is when you take the log of this, that comes down to the front, so this becomes x plus 2 log of 3. So when I say bring down the exponent, it means when you take the log, the exponent drops down to a single level as opposed to like multiple levels. And what you'll end up doing is log of 3 is a number. Okay, so you can treat it as a constant multiplied by a number that's the exponent. All right. And then once you're on that level, guys, it's just a linear equation. Because solving it out, you might have quadratic and so on, but it's a regular equation that you would be solving in like algebra 2. Okay? So once you get it down and you've done all your log stuff, you know, if you've got things multiplied, make sure you split it apart into 2 logs added together, you know, all that stuff. That last part is simply a couple step equation. Okay, so we've got quite a few problems I'm going to go through. Okay? That's the first one, but look, one of these you're going to have to do in the calculator. It'll be the last one I do, just to make sure you're okay with solving one out that you will definitely need a calculator for. All right? By that I mean like actually in the graphic calculator. All right, so step-wise, as I would go through the like little 3-step thing I had. First thing, isolating the exponent that's already done, right? Like 3 to the x plus 2 is by itself. There's nothing multiplied or added. Step 1 is done in the problem already. Nothing to do for that step. So take the log of both sides. For argument, you want me to do log or natural log?
Wow.
So when I do log of both sides, okay, this is to the point now you use the laws of the logarithms to move that exponent down. So since it's exponent, just like always, it drops to the front, like I would show. And then once you're here, essentially just solve it like a regular linear equation. Right? This is x plus 2 times the number. Log of 7, that's a number. These are constants. It's just like if you had a 2 there and a 5 there, you'd use the same one. Okay? So what you would do is, since this whole thing, x plus 2 is multiplied by log of 3, you move it to the other side, you would divide. This is directly opposite. All right, so in the calculator, this is the point where you need to go to the calculator and actually get a number there, right? This would be log of 7 divided by log of 3. Whatever that number equals, what you set the x plus 2 equals. What is it? 1.77? Okay, and then the last step would be just subtracting the 2 over. So what's 1.77 minus 2? Negative point what?
I know, why are you
Negative
doing
three.
that?
I agree.
I know, but why do you?
2.23?
Oh my god. Why doesn't he do log of 3 and then multiply that, like distribute it to the x plus 2? Is that how
You can if you want to.
Can I do that?
Yeah.
Okay.
Well, I won't change the answer, but I wouldn't do that because log of 3 is going to be a weird decimal, right? So it's to distribute it in there, you're just causing yourself more of a headache. Yeah.
Why do you divide the log?
This is even multiplied, right? So if I got something multiplied from the other side, you divide it. Same thing as if I had 2x plus 2 equals 5. I got that by itself, but the x plus 2 equals. Same idea. Log of 7 is a number. What's that? You got to remember that's a number. So these get treated the same way. If you want to do what Olivia said, if you want to make that a number, distribute it, do it. I would. Okay. Yeah.
I just want to know if you do, are you going to do one of those problems in natural law?
Yes. Right here. This one definitely you want to do with natural. Okay, with the one up here now, since the base for your exponents here is e, you definitely want to do natural log on both sides here. Okay, if the base isn't e, then it wouldn't really matter. But the reason you do it here is because if you do natural log of right e, it's just 1, so it kind of like disappears. So it's easy to work with.
What's the difference, like, in the, like, why, I mean,
The
like,
basis
you
is
know,
all that's the natural log is, remember, a log that's base e, which that's your
Okay.
base, right? That's the only difference. But like the last problem, it wouldn't have mattered because I divided the 2 logs. So I would have got the exact same answer. All right, so here's my steps, right? First thing would be I want the exponent part all by itself, which it's not right now because I've got an 8 multiplied by my e to the 2x. So even before you start this, first thing you would want to do is divide it. Okay? And go ahead and make it a decimal, a fraction, whatever. I don't really care. It's probably going to be easiest if when you do 20 divided by 8, you make a decimal. Like what is 20 divided by 8?
2.5.
Okay, because my answers are going to be decimals anyway, I'm not that worried about keeping whole fractions for the end of it. Then next thing, since the exponent is now by itself, you would do the log of both sides. And I said, look, since this is base e, I'm going to do natural log of both of them. All right? And the whole reason to keep this one in natural log is when I move that exponent down, it's going to say 2x times natural log of e is that. Well, the natural log of e is what? Natural log of e is what? 1. So in essence, really, all you're left with is 2x equals whatever that equals, right? Because that's 1. What's ln at 2.5? 0.92, that's fine. And that's a much easier thing to deal with. If you use regular logs, you still could have done it. It's just when you got to this point, you would have been dividing by 2 numbers, as opposed to just saying ln 2.5. So my last step would be divided by 2, correct?
Yes.
So 0.92 divided by 2 is?
0.458.
We're accurate than the numbers around.
No, we're not in chemistry. We're not in chemistry.
Afterwards.
We're not in chemistry. We're always in chemistry. Chemistry's all around us.
If I say it's exactly 20.
I mean, I get the right answer because he says that they're
Okay.
all getting the wrong numbers.
Next thing here. This is all, the font's like real weird there, guys. This is 5, all raised to the power of negative x over 100. Okay? So the power is negative x over 100. I don't know, just when you do the math type thing, it's a 5. Alright, so, right, going through the steps. First thing is exponent by itself. Right, there's nothing multiplied by it on the outside, there's nothing added to it, I don't have to move it. So since it's all by itself, go ahead and take the log of 5 x over 100.
Wait, you don't have to move that.
I will. Okay, I'm just going to set that there. Alright, once you're there, the negative x over 100, right, drops to the front. Okay? Yeah.
Why wouldn't you do 5 by 5?
I can't.
It's log of 5.
Because it's 5 raised to a specific power. It's not like 5 multiplied by anything.
Wait, that's the power?
I know what you're saying though. If it was like 5 times, if it was like 5 times 5, blah, 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 like that, then I could. But I just can't.
So wait, what is the 5?
It's the base.
Okay.
5.
Oh.
Why I said that in the beginning.
I didn't get it when you said it the first time. You had to draw it on a visual.
I know. It's right there.
Okay, thank you.
Alright, so guys, yeah.
So when you do like the natural log of that, all you would do is replace whatever.
Log with
Like,
ln.
so you would be ln 5. It'd be the same exact setup, just with ln. Okay.
Alright, so once you're at that point, guys, you'll realize like the process here, once you get to this point, is about the same. Log of whatever that base is and log of that number always get divided. Okay? So then you've got negative x over 100 equals what's log 2 over 0.43? Yes. That. Alright, and then I would just multiply by 100, well, negative 1. But, yeah. Alright, next one. Okay. Guys, this is going to be like the first one we got to start moving things around. So, doing this one right here, my exponent's not by itself, so I got to find a way to get it by itself, right? E to the negative x would be what I want isolated, if I can. So, if I multiply both sides by 50, that would be 250 over 1 plus.
No, can you multiply? Just multiply by e minus x. Right?
Multiply by what?
E minus x.
Just make it
No, can you just multiply by that? That way it'll cancel. And then
I can
just call it a day.
multiply by this entire thing.
Yes.
But yeah, I mean the one.
Okay, so, hold on, wait. So it would become,
Yeah, it's like a cross. You guys, I found my chapter.
okay?
What is that?
Then, this whole thing. Yeah. Okay, and then, once you're here, I would subtract that 4 over. And then The only other thing is I want e to the negative x by itself. So that now I can divide by 4, because this is 4 times my exponent. Okay, so like this is the case where I'm not raising 4 to a power, so that means like I can go ahead and divide it. So 46 divided by 4 is 5. So since I've got my base of e, I would definitely do natural log here. If I do natural log of both sides, I'm going to skip a step here.
Oh, wow.
That, right? Natural log of e is 1. So
Oh my God, what's going on?
not right.
Oh, my God.
So then the only thing you have to do is find natural log of 11.5.
Where did
Which
you
is
go?
fine.
Where?
It's wait. 2.44 is negative x. Correct.
Oh, no.
Right? I did natural log of this. Right? So
Okay, I have a question.
negative x drops to the front. Natural log of e is 1. So I just let it that.
Then x equals negative x. What?
Okay, now this one here. Any ideas of what I'd probably do?
Wait, hold on, I have a question.
No,
You want two e's.
I have your
You just said give up. You give by.
Okay, hold on.
combine the terms.
First thing you would do. Got it.
Yeah, combine like terms. Okay, you're only
What
an
like
hour late.
terms?
There are no
Oh,
The x's
okay,
are there,
no,
no,
never mind, I
but
lied.
there's a common factor in both. Take
Oh,
out,
wait, or the e.
hold on, take out x to the third and e to the negative. There's an x to the third in both of them. There's an e to the negative 3x in both of them.
I don't understand. I get it. That's the
So it
like
becomes
you divide.
4 minus 3x right there. This is essentially back to how you would treat a quadratic solving or anything with like a polynomial. Because there's two factors here, right? There's one grouping here, one here. If either one of these is equal to 0, you will get an answer of 0, right? Because they're multiplied together. So in reality, what you're doing here, you're solving that equation and that one. I don't have to even touch the log stuff in this case. Because what value of x would make this 0? 0. If I solve this out, you'll get what? 4/3. Okay? So those would be the two answers in this case. This one is just a matter of you recognizing that you have fact. Now, you might run into something like this where you can factor out an exponent and then maybe do the log after that. That could be a case that might have to happen. Or you might have to move the other side divide, whatever. Okay? But if you see a common factor, guys, you always want to bring it out, like distribute it out. Okay.
How did you get x equals 0 for
Just by plugging 0, that 0 times anything is 0.
Oh!
Wait, but
But you can't just plug it in different.
wait, yeah, I have that.
Good, but it's not going to be 0.
Like if you put in 0 for wait.
For this, that'd be e to 0, which is 1.
Yeah. So but 1
Times 0 is 0.
Oh.
These are multiplied together. X cubed times e to the negative 0. They're multiplied.
So you have to plug it in.
That would make this 0. No other number is going to make it 0.
Oh, I'm dumb. Oh, dumb.
They're multiplied.
Oh, yeah, you're right. I'm dumb.
You're so dumb.
Whoa, wait, you might have.
No.
I almost forgot the last thing.
No.
All right, this is the next one. Okay?
Wait, hold on.
All right, so here's the thing. I just switched
Unlike
this
Mr. Clinton.
from, it's no longer an exponential one. This is your log equation. Okay?
That can happen.
So with the logs, guys, that means you're using like the log logs to kind of condense it down. Okay? And then write it in exponential form like you would have done on warm up in the homework yesterday. All right, so if I was doing this, I would look for the logs being the same base, which they are, and I'd recognize that they're being subtracted. So I can condense this to, right, log base 5, x plus 1 over x minus 1, which is 2. Okay? Then from there, for me to actually solve this for x, I need x plus 1 over x minus 1 to equal a number. Remember with logs, right? That's the base. That's the exponent. So 5 squared equals that part there. So this gives you the equation you're working with. Okay? So x plus 1 over x minus 1 equals 5. Then you can multiply your denominator over. 25x minus 25. Then just get x by itself. So that'd be what? 26 equals 24x, right? So x is 13 over 12. Right? Okay? When you got the logs, guys, the only thing you gotta remember is that's base, that's number. But you can't, you don't want to do that, the whole base raised to whatever the power is, until you gotta condense into one log. You got multiple ones like subtracted or added, make sure you combine them in the proper manner. Okay, the last one is one that you're going to have to do on the calculator, guys. So, get a calculator. Got one?
Oh, I have a question.
What? What?
The last part.
I divided?
No, okay, you had x plus 1 equals 25x minus 25. How did you get 26 equals 25?
Add 25, subtract the other.
Oh, dude.
We all have our money.
Not subtract.
Yeah, no, yeah.
Alright, this is the last one, okay? The issue with this one, right, is I've got a log on one side and something other than a number on the other one. Like the last problem I had, logs on one side and I had a number on the other. Okay, which I could solve it out, okay, because I had that going on. This one I don't. Okay, like the most I could do is I could say like e to the x equals 4 minus x squared, but that's not really going to get me anything. Okay, so here's what you're going to do, right? And this goes for any kind of equation this way. I'm just going to show you how to do it graphing wise on the calculator. And this goes for any equation ever that you're doing. Okay, so guys, all that you're going to do, right, doing the graphing method in the calculator would be to graph both sides of the equation. Like the left-hand side is just x. So if you just graph y equals x, that's the left-hand side. The right-hand side is natural log 4 minus x squared.
Where's natural log?
Right? Right by the 4. Okay? Now, if you remember, guys, right? Solutions, in terms of graphing these out, guys, the solutions are where they intersect. Forgot, right? There is a thing on the calculator that actually does intersections for you, right? It's second trace. Right there, 5. Does the intercept. Because I want an actual estimate here of using that function on the calculator.
Wait, you just hit second trace?
Do second trace,
Yeah, and we get
right? Go down to 5. You can just hit the number 5 or scroll down. And then what it's going to say, right, is first curve, second curve. First curve just means first the one graph you want to pick. The second curve is the other graph. Like in this case, we've only got 2 graphs, so I don't really have to do anything besides hit enter twice. Okay? If I have more than 2 graphs, then I'd have to distinguish which ones I'm looking at. The guess doesn't matter because there's only one intersection point here. If there were multiple intersections, then when it comes time for the guess, you would just use the left and right arrows to scroll close to where the intersection is. Okay? So then if you hit enter on there, it gives you the X answer right there. So there's my answer. My answer is X equals 1.06.